Okay, logicians, I'm on 7D, interactive set 2, and this is number 3 as per request. So here we've got a truth table. Here's our compound statement. P, if it's the case that P is true, if and only if not Q, then S. That's how that reads. So as always with the truth table, we have the truth values of our simple statements set up over here on the far left, according to the standardized format that they're always done. And then over here, we have our the compound statement with the truth tables from this column, from each of these columns carried over. So for ease of visualization, and they're placed underneath each of the simple statements. And then our job is to figure out the truth values of the logical operators. So the first thing we want to determine is what's the order in which we're going to need to determine the truth values of the logical operators. And the first rule is go as far inside parentheses as you can. So in this case, we've got two logical operators inside the parentheses. Now we can't start with triple bar because in order to determine the truth value of the triple bar, not only do we need to know the truth value of P, but we need to know the truth value of not Q. Now we know the truth values of Q, but not of the not Q. So we have to start with this tilde, the negation sign. Okay, so let's go line by line. If Q, and here's what I'm doing. I'm looking at the truth value of Q in order to determine what the truth value of not Q would be. And it's just going to reverse the truth value of Q because, of course, if Q is true, then not Q is false. And if Q is false, then not Q is true. Okay, now I'm in a position to determine the truth value of the triple bar. And remember, I'm going to be looking at the P column and the tilde column, right? Because this tells me the truth value of everything that's on this side of the triple bar. Okay, and you're for all of these truth table problems, you're going to need to know the truth table definitions of the logical connectives by heart. Those are in the PowerPoint and they're in the textbook. So you're going to need to know when is triple bar, tilde, horseshoe, dot, and wedge, when are they true and when are they false? Now with triple bar, a triple bar is going to be true if both sides of the triple bar are true or both sides are false. So if they've got the same truth value on both sides, then triple bar is true. But if it's a mixed bag, then it's false. So here we got a true and a false, so triple bar is false. True, false, triple bar is false. True, true, triple bar is true. True. There's a false, false. That makes triple bar true. And here's a mixed bag again, so triple bar is false. All right, now we are in a position to determine the truth value of the horseshoe, the conditional sign, which is the main operator of this whole compound sentence. So we want to highlight it here. That's what we do. And how did I know that was the main operator? Well, it's the last one that it's possible to do. It's the one that's outside of the parentheses, and main operators are never inside parentheses. So those are two clues. It ranges over the entire compound statement. The antecedent includes everything that's in the parentheses, and the consequent is the S, and that covers everything. Now, what are the columns that I'm looking at to determine the truth value of a horseshoe? I am looking at, quote unquote, the main operator of the antecedent, that is, of this whole compound sentence, which is the last one we did here, triple bar. So this truth value right here underneath the triple bar is the truth value of the antecedent. Whereas the truth value under the S is the truth value of the consequent. Those are the two columns that matter now. Now, the other thing you have to know is when is a horseshoe true and when is it false? A horseshoe is a tricky one. You have to memorize and study this one. It's not going to be obvious or intuitive to you. Triple bar is always true except under one condition. When the antecedent is true, but then the consequent is false, triple bar is false. In any other circumstance, triple bar is true. All right, so for example, here we have line 1. The antecedent is false and the consequent is true. that makes triple bar true. Because anytime the antecedent of a conditional statement is false, it's impossible to falsify it, no matter what the consequent ends up being. I talk about that more in my other lecture video, so I won't beat that dead horse now, but pay attention. That's a confusing one, but if the antecedent's false, horseshoe's true. Same on line 2. Now line 3, you've got antecedent is true and the consequent is true. So again, the horseshoe is true. Now, line 4, we've got antecedent true, consequent false. Red alert, that's when conditional is false. Sorry, false. And here we got a true, true, so it's true. True, false, red alert, that's false. False, true, true. False, false, true. I know if you're confused by those last 2 moves, then you need to restudy the truth conditions for the horseshoe. But that's how we run that one.